the Coalition for the Deschutes. A little bit about our organization is we work to restore the Deschutes River so that fish farms and family can thrive. One of the big callings that we have found with our organization is that really is about building bridges in our community. We've really found that there are many stakeholders in the Deschutes River Basin that have a vested interest in what happens to our water. And really the coalition is about building those bridges so that we can come together and work together. Tonight, I am honored to introduce Dr. Anders Carlson. He has his PhD in glacial geology and oceanography. He is trained as a climate scientist and glacial geologist. He's worked on glacial changes projects in Alaska, Antarctica, Arctic Canada, Svalbard, here at home and many other places. He is going to talk to us tonight about the vanishing glaciers in Central Oregon and Oregon. And
take it away. Thank you.
Get away.
Okay, thank you everyone for coming tonight. Let me pull up the slideshow here. And yeah, I want to talk today about the work we conducted last summer as part of the Oregon Glaciers Institute. We are a very new nonprofit. We formed last May during the lockdowns, and now have conducted some research on the changes in Oregon's glaciers and are bringing this back out to the people. So we went and conducted a survey of all the glaciers in Oregon, but I want to focus in tonight just about the Deschutes Basin and mainly the upper Deschutes Basin, coming back to all of Oregon near the end of the talk. And the first thing is that this same talk could have been given 83 years ago. In 1938, Kenneth Phillips, who is an engineer at the U.S. Geological Survey, but also then an active member of the Mazamas Mountaineering Club up in Portland, published a paper called Our Vanishing Glaciers in Oregon. And basically to just kind of take a longer perspective here on the history of glaciers in Oregon and the study of glaciers, the study only goes back to the 1837, 1840s when Louis Agassiz, the godfather of glaciology, published his book, The Studies on Glaciers. This was observations in the French Alps. And at that time, they also came out with the idea of past ice ages, but at that time, they thought the lower 48 of the United States was ice-free. There were no glaciers left in the lower 48. And that was up until 1870 when the first glaciers were discovered on Mount Shasta. And then a few days later, they were discovered on Mount Hood. So up until 1870, we didn't think we had any glaciers in the lower 48. In 1885, after some extensive studying, U.S. Geological Survey geologist Joseph Diller, who you might recognize the name of Diller Glacier then on Middle Sister, he commented about the Three Sisters region as being probably affording the most interesting field of glacial studies in the United States with the exception of Alaska. So the upper Deschutes was considered in the late 1800s the best place to study modern at that time glaciers in the lower 48. You fast forward then to 1938 with Ken Phillips publishing Our Vanishing Glaciers. And then in 1939, he wrote another paper in the Mazama Journal called Farewell to Shoals Glacier, documenting the first disappearance of a glacier in Oregon. And at the end of this paper, he wrote this kind of prescient little sayings. Why are our glaciers receding? Who knows? Maybe perhaps mountaineers of fairly near future may look upon empty cirques of Mount Hood as a normal condition. So in the late 30s, people were worried about glacier retreat and what it could mean. And then 1941 happened and we entered World War II. And we had other things to worry about here in the United States. And after World War II, with a renewed kind of chutzpah in the United States, the USGS went about making a topographic map series that we all know and love and use to this day. That began after World War II. And in the 1950s, Oregon was listed as having 36 officially named glaciers in that the first generation of topographic maps. And in the case of Oregon and in the Cascades, those maps have never been updated. So it's been 70 years since anyone actually redid the outlines of the glaciers in Oregon or their names or what exists. So the maps in the Cascades are very out of date. In the Wallowas, they were updated in the 80s. But the Cascades got to go back to the 1950s, and the rest of the US lower 48 all been updated in the 70s, 80s, and maybe into the 90s. But they skipped the Cascades for some reason. So that's kind of where we leave off our talk here. So Oregon had 36 named glaciers 70 years ago, of which 35 are in the high Cascades here, with the southernmost one being here, Lathrop Glacier down on Mount Thielsen. And then there was one named glacier in the Wallowas. Now, a lot has happened since the 1950s. This is just a picture here kind of showing you the retreat of ice. This is Hayden Glacier up here. There's Middle Sister. And this is the retreat of ice that's occurred in the late 1800s. Hayden was down right here at the base of the picture. I'm taking this photo. So what has happened? Well, we can look back at what the glaciers have changed since the 1910 and since the up to the 1940s. But since then, not much has happened. This is a photo here of Collier Glacier taken in 1910, showing ice filling the hole on the west side of North Sister, filling up the whole basin here, and this is its moraine. 1949, you can see large amounts of recession of Collier. And then in 1990, from the same vantage point, as my PhD advisor took this photo, ice hasn't changed much since 49 to 1990. And over here, this kind of highlights the changes here. This graph here is from Jim O'Connor of the U.S. Geological Survey, conducted work in the early 90s. It came out in 2001 on the potential for hazards in the Three Sisters region and on Mount Jefferson. And this is tracking the change in glacier area in square kilometers on Mount Jefferson and on the Three Sisters region. So the whole combined area, the dots being then observations they have photographs from. And you can see from 1850s or so, which would be about the end of the Little Ice Age, up to the early 1900s, you have a lot of glacier retreat, at least in the Three Sisters. You can see Jefferson, there's only 3 data points, so it's hard to say what's going on there. But retreat up to the 1930 to 1920, 1940, and then it levels off. In this paper, the research for this work was finished in 1991, but it's a U.S. Geological Survey publication, so it's the federal government. It takes 10 years to get that published, so it came out in 2001. But not much changed in the glacier extent during that 1950s up to the 1990s period. Now there's a jump then, where if we look at the climate, the actual climate records we have for the high Cascades really only go back to the 1990s. So we had this study up to the 1990, and then after 1990, we actually have temperature observations, but we don't really have any observations of the glaciers. And even despite the USGS making those maps of the Three Sisters region and Mount Jefferson, that was never translated over into the topographic map series. So that data was collected, but never utilized to update what is going on with the glaciers officially recognized by the federal government. So if we look at the temperature records here, this is from what's called the SNOTEL site, which is National Resources Conservation Service maintains. These white dots are these snow telemetry sites, which have snowpack, but also temperature. And they consistently started working in around 1990. And if you look at, this is an average temperature change for these ones in the Cascades here. Over here are the Wallowa ones. This is for the Cascades. And the bottom graph is showing you change in summer temperature, June, July, August. And the top graph is showing you mean annual temperature. And between 1990 up to about today, the Cascades, regardless of where you are, have been warming at a rate of about 0.7 to 0.8 degrees C per decade. So that's about 1.5 degrees Fahrenheit per decade. That's a lot of warming that's occurring. And that's got to have done something to the glaciers that weren't doing much up until between 1950 and 1990. But after that, we've been warming at a very rapid rate. So this is what kind of where we were left off at. And our question then for this talk today, and what we went out to address this past summer, was what is the state of the Deschutes glaciers? And our goal is how many remain? What ones are active? What ones are gone? And this was a very binary approach, just as like, is it still an active glacier or not? But such a simple question had not been asked since the 1950s, and really not since the 1930s, because the 50s maps were made by cartographers that were sitting in Reston, Virginia, where the main U.S. Geological Survey office is. They weren't glacial scientists out in the field actually checking these things. They were people who had been in the, in the Army, World War II, fighting Nazi tanks with the air photos, and then turned around and used those skills to map out glacier, what they thought were glacier extents from the same type of air photos in the 50s. So it's been a long time since experts actually looked at the glaciers in Oregon. So before we ask what is the state of the glaciers, we should first figure out what is a glacier. And this is important because this can partly explain, you'll see here later on in the talk, there's been a lot of confusion about how many glaciers there are in Oregon. And a glacier is an ice mass that flows under its own weight. So that's the physical definition of it. It's a physical state where there's an ice is thick enough that the ice starts to deform like silly putty. And for it to occur, ice has to at least be 100 feet thick or 30 meters thick. And ice thinner than that usually won't deform, and so is considered stagnant ice and is not an actual glacier. Glaciers have to move under their own mass. Another way to think about glaciers then is that they're a physical manifestation of climate on the landscape. And for a glacier to build up ice to be 100 feet thick, you first have to have snow stick around throughout the summer and to accumulate over time for the snow to turn into ice to then eventually get thick enough to deform and flow down the hill. And so these glaciers show you that in that basin, it's cold enough in the summers, or it snows enough in the winters, or a combination of the two, that snow sticks around year round. And so the snow line, the end of summer snow line, is below the summit of the peaks. So that snow accumulates in this cartoon here, what's called the accumulation area. Obviously, the accumulation area accumulates snow. And eventually that snow builds up over decades to be turning into ice. So just like if you don't shovel your driveway after a snowstorm and you never shovel it and you keep driving your car over and over, and eventually you get a nice ice layer underneath where your tires go. That's kind of what happens up in these high alpine zones. As snow sticks around and it turns into ice. And once it's thick enough, it flows down the hill under its own weight, driven by gravity pulling it down, to where it then can eventually melt, and it'll flow all the way down until it reaches a temperature where the summers are warm enough that it completely melts all the ice that can be supplied. That's where the glacier ends. And so this glacier is telling you that above this in this higher elevations of this basin, it's cold enough during the summers and it snows enough that we always will have snow there. And then eventually it flows down, and the terminus of the glacier where it ends tells you that those summers are warm enough that they'll melt all the ice that can be supplied from up in the accumulation area. And that's down here is called the ablation zone. And how ice ablates usually is by melting. That's the most common way. But it can also, if it's terminating in a body of water, a lake, or if you're up in Alaska and Glacier Bay into the ocean, it can calve off icebergs. And then the one other way it loses mass is called sublimation. And this is the direct transfer of ice into water vapor. And we all experience sublimation because we put ice cubes in our freezer and we have them in the ice tray, and then we want to finally make a cold drink months later. We go back in and the ice cube tray is completely empty of ice cubes. Our freezer didn't melt, warm up and get above 32 degrees Fahrenheit. That ice slowly just transferred into water vapor in the air. So that's sublimation. And now an interesting thing here between this manifestation of climate is between the accumulation zone and this ablation zone is what's called the equilibrium line, where the snow, it's just warm enough to melt all the snow, but not anything more. So that's right. That is the zone, but that zone is called the equilibrium line, and the elevation of that line in the atmosphere. So where it is in the atmosphere is equal to the mean annual freezing temperature in the atmosphere. So another term for this snow equilibrium line is the end of summer snow line. So where you see snow in late September, early October up in the Three Sisters or on Broken Top, that is also the equilibrium line. And that elevation is where the mean annual temperature, not the summer temperature, the mean annual temperature is 32 degrees Fahrenheit or 0 degrees Celsius. So these things are very representative of the climate. And in a way, you can think of glaciers as being climate recorders in the high alpine zone. So, you can put up a weather station. These glaciers are telling you the average climate on a decade time scale. So their changes reflect climate change as well. So looking here, just an example, this is Crook Glacier up on Broken Top here. And this is the headwaters of Bend's drinking water supply through Crater Ditch. This water, the meltwater from Crook Glacier, is brought over a divide and taken directly into Tumalo Creek, where it then is used as the drinking water for the city of Bend. And you can see here, this is a photo from late August of last summer. And this is the 2019-2020 snow here is my colleague Aaron Hartz for scale. And you can see this was a bad year, it turned out in the end for the glaciers. I don't think Crook Glacier accumulated much mass, but if it snowed the next day, this would have been the equilibrium line of Crook Glacier here. And you see down below it, there's a couple previous years' snow, and then below that here is bare ice. And this would have been the equilibrium line of 2020. And down here, I think this layer here would have been 2016, because 2015 was a really bad year for glaciers. If you remember, it's very low snowpack, and the summer was very warm. You can see how this works then too on the Villard Glacier. This is on the north side of North Sister here. So here's Villard. And this glacier here, here's that snow line. And then you see these annual bands here of the ice moving down slope under its own weight. And each one of those bands is 1 year. That dark layer accumulates into summer when we have forest fires and it's dusty out. There's not snow in the landscape. So wind's blowing dust around, and that accumulates on top of the snow. And that makes a dark band. And you can count these. And we're able to count more than 50 layers in Villard Glacier here. So this glacier, the oldest ice in this glacier is pre-1970, basically. And so you can see this ice is then flowing downhill to where the terminus here is defined by it is warm enough at this elevation in the summers to melt all the ice that's being supplied from up top. Now, glaciers are also not just a climate indicator and also a pretty thing to ooh and ah over on vacation or when you're out hiking or running in the mountains. They're also a natural reservoir. These things store our water in the high alpine zone. And you can think of the mountains as water towers, and the glaciers are all at the top of the water tower holding this water that we use then in the late summer to early fall after all the snowpack's gone. So in Oregon, 85% of our water usage is for irrigation, and in the regions of the Cascades and also up in the Mount Hood and the Three Sisters region, we're getting a lot of that. The irrigation districts are using this meltwater when it comes to late summer, early fall. What'll happen if a glacier disappears is you'll have a permanent drop in your stream discharge in the late summer to fall. Some of these streams will completely run dry, depending upon how much is coming from glaciers versus groundwater. But you're going to lose that glacier source, and if that glacier disappears, if you're going to keep up that, you have to build a new reservoir, and that's going to get expensive. So we want to keep these glaciers here. These are Mother Nature's dammed up water for us. It's just frozen here. Another thing to think about is that water source is 0 degrees centigrade, 32 degrees Fahrenheit. So that's really cold water that's being added to the streams. And the real interplay between irrigation districts and the water being left in stream is the temperature of the water. So not only are you going to have less water in the stream, just like a pot of less water in your pot on the stove boils quicker than a larger pot of water, than more water in your pot for the same size pot. You're going to not only have less water in the streams so it can warm up more, but the water you're removing is at freezing temperatures. So this will exacerbate, glacier disappearance will exacerbate not the conflict, but the allotment between, well, how do we keep the streams cold enough for salmon and trout while also still being able to conduct our agriculture and ranching. Another issue too is that those cold streams cool the forest. So you lose this freezing temperature water source, you're gonna have warmer streams, those are warmer forests, and that increases your fire risk. Not only the chance of having a fire, but when the fires will burn, and those are supposed to happen naturally, they'll be more intense because the forests are just hotter to begin with. Another issue here with glacier retreat is that you're destabilizing this landscape, and this landscape has had glaciers on it for centuries, and you're removing that, and you're exposing then a lot of loose debris, glacial sediment that is not consolidated. And in addition, you're making a lot of water from the glacier melting, and that leads towards landslides, debris flows, in addition to flooding. Here, and I'll show you an example in a second, but you can see here, this is an example of Lynn Glacier on North Sister. Here's what it looked like in 2004 when I was a graduate student. And here's what it looked like last summer. And so you can see the amount of loss there, and it's beginning to build up. A lot of this sediment here is just sitting there ready for it to be mobilized by a fair amount of meltwater or rain on snow event, and you can get a landslide coming down. And this is a critical component here in Oregon. Nobody's monitoring our glaciers. So we monitor, if you throw up a dam on a river, we monitor that water behind a dam, that comes in, what goes out, how much water is there. That's not occurring with our frozen reservoirs or frozen water behind behind a dam, the glacial moraine. So nobody is actually conducting any study right now on how much is stored up there and what's the risk running from that. And here's just an example here at the head of Wychus Creek. So this is behind the little Ice Age moraine here that was left by Prouty Glacier, you can see right here, that drains into White's Creek. And this is a large marine dammed lake right behind it that is being fed directly by melting of Prouty Glacier. And this dam could easily, this is all made up of just unconsolidated sediment, and this could easily be breached by excessive melting on Prouty Glacier if it's a really warm summer or we get some weird rain on snow events. And this could then flood downstream and go right through the town of Sisters. And there's not a single thing being done to monitor how this is changing or evolving as a hazard. And this is true for all the Cascades. So there's a lot of issue here with this lack of monitoring the changes that we're seeing in our glaciers and in the high alpine landscape. So back to the question here, what is the status of the glaciers in the Deschutes Basin? We got to figure out how we tell the difference between a living glacier and a dead glacier. And a living glacier being one that is still deforming under its own weight, and a dead glacier is one that's no longer moving. There can still be ice on the landscape, and that was glacier ice, but it's no longer deforming, and therefore it's no longer flowing under its own weight, and so it is no longer actually a glacier. It is a stagnant ice mass. And so this case here, here's Lynn Glacier, which is still technically a glacier, and I'll tell you why in a bit. For one, glacial flow makes crevasses. And so when I said that 100 feet thick of ice to deform under its own weight, the upper bits of the ice on the glacier don't have 100 feet of ice above them to put the pressure on it. So they're still brittle and they crack and break. And with the ice flowing at the base and moving, the upper ice has to catch up with that moving ice. And so it breaks to catch up with it. And those make crevasses. So this is an example here, Bend Glacier on the north side of Broken Top. And while it's not doing well, it does have crevasses on it, you can see. And so the ice is still moving. And so Bend Glacier is still an active glacier. Another way you can tell glacier motion is that basal movement, that moving at the base of the ice erodes the bedrock, and that makes what's called glacial flour. So you can go to where the heads of the meltwater streams coming out of the glacier from underneath and look at the water. And in this case here of Carver Glacier and South Sister, there's a lot of sediment in it that's being produced by this glacier moving over its bed and eroding the substrate. And so this presence of flour tells you that there's active erosion of the bed underneath the glacier, and so the glacier is still moving. And lastly, here, you can look at the shape of the terminus, so the end of the glacier. If it's flowing out into this warm air that's acting kind of like a buzzsaw chopping off bits of deli meat, it's so warm it's just slicing it away. That ice has got to be flowing forward, so it's going to be convex. It's going to look like your silly putty that sits on your table, and it's got a bulbous edge. And that shows you the ice is flowing forward, whereas if it's not flowing, just melting back, it's going to melt back and be concave. In this case here of Lewis Glacier on South Sister on the south side, it's convex, and it's still flowing in an active glacier there. So you can just look at the shape of the ice and determine if it's a active glacier or not. So let's then zoom in now on the upper Deschutes Basin here and look at the glaciers within that basin and how they are remaining. So this is the official glaciers of Oregon, and we'll focus here just up here on the upper Deschutes Basin itself and take a short tour of the glaciers here. So we can start off here at Broken Top, and on the left is what is the federally recognized U.S. Geological Survey's most recent topographic map extent of the glaciers and permanent snow bodies on Broken Top. On the right is what a satellite image shows what Broken Top looked like in October 10, right before the first snowfall. And the two are very different. There's a lot less white on the photo than there is on the map. And this is just the direct color of the landscape. There's no kind of enhancement or heat color thing that would go along with some satellite imagery. And back to Bend Glacier here on the north side of Broken Top, which is draining into White's Creek there towards Sisters. It's still an active glacier. As I said, we have these crevasses here, but it's not doing well. The glacier used to extend all the way up here, and you can see some ice up here, but there's this bedrock band that's broken through here, melted through. And the active part of the glacier is down here. And this is a photo from late August, and you can see this little bit of snow here. By the time the end of the summer occurred, which is the beginning of the first snowfall of the winter, that was mid-October. This was all gone. So Bend Glacier didn't have the equilibrium line for the last summer was above the elevation of Bend Glacier. It gained no mass. It only lost mass last year, which is unhealthy. So it's being starved right now for new ice being added to it. it's only melting away. So the way of thinking of it is it's a runner having to run a marathon, but doesn't get to take in any calories. It's only using what it has stored in itself right now to continue to flow. Going over to Crook Glacier, I showed you that before. That's still an active glacier as well. And this is the headwater of Tumalo Creek. And it's sitting there doing okay within the cirque. We went out to do this survey. We thought Crook was going to be gone. And we were quite surprised that it's actually relatively doing okay for being as small it is and at its lower elevation. Now, those are the two named glaciers on Broken Top. There's a couple other ones that existed that never were named, and the most visited one is probably the one that's above No Name Lake. This lake that was never named, and it has been called East Bend Glacier unofficially, and it's a little smearing of ice up here that doesn't show any crevasses anymore. So that's what's left of East Bend Glacier that was extending down and filled up the basin that is No Name Lake nowadays. And that's gone, or still a bit of stagnant ice. Another one is what's called unofficially called West Bend Glacier. So here's Bend Glacier, and West Bend is to the west. And you can see the moraine here that it deposited, and there's nothing left in it anymore. It's just bare bedrock. And here's Bend Glacier proper, but then East Bend or No Name Lake being over this little col here, this saddle. So West Bend Glacier is completely gone. So the 4 glaciers that were on Broken Top, 2 are gone and 2 remain. So 50% are gone. Disappeared. We can move over now to the 3 sisters here. We'll start down, and this again here is what's on the USGS map. If you use a US Forest Service map, the most recent of those are from 2016. They use the same ice extent as the USGS, and that ice extent is from the 1950s. This is what it's officially recognized, and here's what it looked like on October 10th. And again, there's a lot less white on the air photo, the satellite image, than there is in the topographic map. We could come over here and start on South Sister at Clark Glacier, and this, we threw a funeral for this glacier in October and had a casket on the steps of the Capitol in Salem, as well as holding a wake for the glacier up on South Sister. All that's left of Clark is a smearing of ice here. And I think, I don't know how this goes, but there's a couple dogs here of ours for scale, showing you that the glacier is getting down to dog. You know, you can put a dog on it, and the two look kind of, there's not a huge difference in the difference between a glacier and the size of a dog. So there's not a lot left here on Clark, and it's stagnant ice just left a little bit there. We can move over here to Lewis. And as I said before, that one is an active glacier still and is doing relatively well compared to Clark being completely gone. Then Prouty here on the northeast side, where I showed you the developing potential for large-scale flooding down to Wyches Creek. Prouty is still an active glacier. You can see some crevasses on it, but it is like Bend and didn't have any accumulation of snow last year. The end of summer snow line, equilibrium line, was above the elevation of Prouty Glacier. So it is not doing well, just like Bend is not doing well. It is being starved for sustenance, starved for snow and ice. Moving around now, we get to the north side here, and this is where things got a little wonky. We have Carver Glacier on the north side of South Sister, but Carver Glacier really is 3 glaciers, of which they just happened to probably, they called all 3 of them one glacier on the map. So here's Carver proper in the middle here, which is this middle ice mass on the map here, and that's still an active glacier. It's got a terminus here that's convex, and then that's also where you have a lot of melt. That you can see the stream, the meltwater pond here, being filled with glacial flour. Now above it, if you look here, there's this moraine above the glacier here, and that's up into this ice mass here, which we're calling unofficially South Carver Glacier. And this is a good example of stagnant ice that has relatively recently stopped moving. And so this is recently stagnated ice. There's a lot of ice in here. It's just too thin to deform under its own weight. And so it's now no longer an active glacier. It's a stagnant ice mass. And so South Carver Glacier is no longer an active glacier, though there's still some ice in there melting. Then lastly is North Carver Glacier, which extends down here. Here's Camp Lake, which probably many of you have been to and camped at. And it was this ice mass extending down to Camp Lake, and it deposited this moraine here, or actually right here, running along. And that is, there's a little bit of glacial ice left here right now, but other than that, it's no longer there and is gone. We can hop over now onto the other side here into the Willamette National Forest and go to Skinner Glacier. And that again is the one that was actually 3 glaciers, of which 2 remain. So here's 1, 2, 3 are the 3 different ice areas of ice that were called Skinner Glacier. And South Skinner Glacier, this uppermost one here, is just a snowfield now. There's no glacial ice left there. And you can see the moraine deposited. We hop over this moraine down slope. We come to what we just said is Skinner proper, the middle one. And this has a convex terminus here. And so it's still an active glacier. You can see the nice banding here showing the glacial ice flowing. And we move a little further down, we go to what we call North Skinner Glacier. And this as well, again, is an actively flowing glacier here. What's cool is these debris bands here show this is rock being brought up from underneath the ice from it eroding a knob of bedrock. And so this is showing you there's definitely active erosion occurring underneath this glacier at this point. So so the Skinner glaciers, 2 out of the 3 still remain. And then even further highlighting how how much little effort was put into mapping of ice in this region, we discovered a whole new glacier on South Sister last summer. And don't have a name for it yet, but it's on the north side of South Sister, and it is above Skinner Glacier, and it is on the USGS and US Forest Service maps, bare bedrock here. And it's actually an active, healthy glacier sitting in this big carved out amphitheater, which is called the Cirque, that's carved out by ice. And if there's ever a place you would put ice on South Sister, the first place you would put it would be on the north side of the thing in a giant amphitheater where it's out of the sunlight. So this is right where you would put a glacier, and lo and behold, turns out scientific theory is correct, and there is a glacier there, just nobody bothered to put it on the map. So we found a new glacier. It's not like regrown or it's something cool. This glacier's been there for centuries. It just never was mapped and never recognized and documented by humans. You see the crevasses in it. It's got a lot of rock falling, which helped obscure it, but there's still this active glacier on the north side of South Sister. So brand new one. We can continue on then to over here to Eugene Glacier, just nearby it. And so when they put Eugene on the map, they just forgot to look at around the corner here, add this other glacier there. And Eugene is an example here of a glacier that just is probably beginning to stagnate. So it's no longer active ice. It used to be, and it's just becoming concave and is breaking apart. And so this very recently stagnated, this ice here, and is no more. And lastly is Lost Creek. We put eyes on it from a distance, but I didn't have a good photo of it. And this is one that's not really contested that it's still a glacier or not. It's got ice there. This is actually recent rockfall that's on top of it. And it's still a relatively large flowing glacier on the northwest side of South Sister. So Lost Creek is still there on this satellite, and you can see it on the satellite image. So let's move over to Middle and North Sister. And we can start here with Irving Glacier on the south side of Middle Sister. And this is a recently stagnated ice mass as well. It is no longer actively deforming. You can see it's got a concave margin here. There are actually 2 Irving glaciers. There's a separate ice mass, this lower one down here and this one up here. South Irving Glacier is also stagnated. These crevasses here are not from ice flow, rather this lake here extends under the ice. And so this is the ice collapsing in on this cavern, subglacial cavern that occurred there. There are other glaciers here too. Above Chambers Lake, there's a big moraine. You can see a little bit of ice there. This is an unofficial one, but there was Chambers Glacier in Lowmount. That one is just now stagnated and gone. And on top of that, there was a glacier right above Camp Lake too. So right near the lower part of Carver, that is right here. You can see this little moraine running along that is now gone as well. So these ones are never officially named, but they were mapped as snow or ice bodies on the maps, and they were glaciers, but no more. Moving a little further north, up on the Middle Sister, and here's North Sister. Diller, and named after Joseph Diller, the geologist I mentioned at the beginning of the talk. That's still an active glacier here, but it's definitely retreated a lot from where it was back in the day down here at this moraine there. And then Hayden Glacier, which is the largest glacier by volume within the White's Creek drainage. Prouty's bigger one by area, but not by volume here. So Diller and Hayden are still active glaciers there. We can move around the corner here to Thayer on North Sister. That one is gone. This is just snow. If you look at a satellite image from we took this photo in mid-August, and you go back in October, this is all gone. It's just bare rock. There's no ice whatsoever or snow left. So Thayer Glacier is completely gone. And I showed you Villard already on the north side of North Sister. That is still an active glacier here moving along. This little guy, but it's still there moving. And now in between Villard and Lynn is this thing here, this snow or ice body here, and that was actually a glacier. We called it Crack Glacier because it's kind of wedged into the crack between Lynn and Villard. And it is sitting here. This is nice moraine deposited by the glacier, a little lake behind it, but there is nothing left there now. So bare bedrock. But there was a glacier there, and it deposited this moraine, and there was ice, snow or ice there in the 1950s. It is now gone. Then lastly here on the north side is Lynn, and that it's kind of like right on the cusp. We think we saw some crevasses in there, so like right there and there. So probably still is technically an active glacier, but you go back in a year or two, this thing will probably be a stagnant glacier at that point. So Lynn is near the end of its active glacier designation. Finally, coming around to the west side, here's Collier Glacier, which is definitely still a glacier. Looking north, you can see we were out in the field at this point, late August, early September, right before the fires were coming. And this is when you started seeing smoke rising up from near Portland. And some of our photos looking south started getting smoky by the end of this trip. And here's the moraine down there. Now, the problem with Collier Glacier, despite being quite large and volumetric being the largest glacier in the Three Sisters region, but it's on the west side in McKenzie River Valley drainage basin. It was not, again, it still had snow at this point, but this is at the top of Collier Glacier, so right up here. And there's an ice axe. Here's glacial ice. Here's the snow. There's an ice axe of snow there. And this is I took this photo on September 2nd. It still had a month and a half to go. So Collier gained a little mass. You look at the satellite images, but it did not gain much. And it mainly lost mass last year. So last summer was not a good summer for glaciers. And finally, Renfrew here on the west side, between Middle and North Sister. This is nearing its end as well. So this is kind of probably what Eugene Glacier looked like a couple years ago. And you can see it's still got convex shape to it, but it's splitting apart into smaller, different ice masses, and is probably nearing the end of its lifespan as a active glacier and moving towards stagnant ice again. So coming back here now to our question, what is the state of the glaciers in the Deschutes glaciers? Well, if we look in the upper Deschutes Basin, so this would be on the east side of the Three Sisters, and including Broken Top, there were 17 glaciers in the basin, of which 10 remain today. That means 40% of the glaciers have died off in the last 70 years. If we include then all the glaciers on the summit, so we include the glaciers on the west side that are also draining into the McKenzie Basin, there are 29 glaciers on these summits, and 16 of those remain today. So we've lost 45% of the glaciers on either side of the drainage divide in the Three Sisters Broken Top region. That's a lot of ice loss. Now we can expand this and go to the whole of Oregon. And so this is a list of kind of getting to our wall of loss. So it's not much different than the Vietnam Wall in some ways, and Vietnam Memorial in DC. But of the official glaciers in Oregon, these are all the different summits: a Hood, Jefferson, the Sisters, Broken Top, and then Mount Thielsen and the Wallowas. I've drawn a line through the ones that are gone here. And that's about 30% of the glaciers that are officially named in Oregon are gone. If we include now the unofficial glaciers, it gets a lot worse. And for instance, the Dutchman Glacier was on Bachelor up until the early 80s. I didn't include that in this presentation here, but there was still crevasses in like 1981 on Mount Bachelor. And the Wallowas had more than 10 glaciers, of which only one was named in the 1950s. So there's a lot of ice loss that's occurred in Oregon. And if we put these by the numbers in the 1950s, Oregon had at least 63 glaciers, and 36 of those were named. Today, we have 29 glaciers, of which 26 are named. And this map over here is showing you all the different glaciers again, Wallowas and the High Cascades, and I put suns in there for the glaciers that have succumbed to the sun and are no more. And then there's little snowflakes for the ones that remain. And you can see they're just here in the Three Sisters region, Mount Jefferson, and then Mount Hood. Jack Glacier and Three Finger Jack is gone. So 54% of Oregon's glaciers are gone. And that die-off is the highest number I've seen anywhere in the United States. And very limited studies have been done like this, but that's very high number. As I said, They're limited to these summits here. Wallowas, Mount Thielsen, Mount Bachelor, and Three Finger Jack are all ice-free. And what used to be the southernmost glacier in Oregon was on Lathrop Glacier down here on Mount Thielsen, is now actually Crook Glacier on Broken Top, which is the headwaters of Bend's drinking water source. So there is the water in the taps in Bend is initially sourced from this glacier, which is the southernmost one in Oregon. Now, this die-off is climate-driven. You can hear about people talking about, oh, we don't know the natural variability of these things, and maybe this is a natural cycle. Well, in this case, glaciers respond to long-term climate change. It takes a decade or more to actually really start making these things respond and change. And we can do a quick calculation of how much warming would have had to take to raise the equilibrium lines, those snow lines above the glaciers that disappeared. And so since 1990, the glaciers that have died off would require about 3 degrees Fahrenheit of warming to occur to raise these equilibrium lines over 1,000 feet to 1,200 feet. So that, oh wait, no, this is how much, all right, I got that backward here. So the glacier die-off to get rid of these guys would require the equilibrium line to rise more than 800 feet. Now the warming that's occurred since 1990 is about 3 degrees Fahrenheit, and that would raise equilibrium lines by 1,000 to 1,200 feet. So the warming we've seen since 1990 is more than sufficient to have caused the stagnation of these glaciers due to them no longer getting snow because the summers are too warm for snow to stick around to turn into ice for them and feed them. And the short story of that is that the maps are way out of date. And so if you compare here what is on South Sister to what it actually looks like, the two just are very different images of Oregon. And if you're sitting there thinking, I'm going to go hiking and, oh, the glaciers in Oregon are doing great, look at the maps, there's all this ice on these summits. In reality, you go out and look at it, it's not these snow-covered peaks that we like to think we see. In the end of the summer, they're looking like this, and it's not a pretty state. Now, for the future here, it gets only worse. The glacial loss, I think, here is probably the best evidence we have in Oregon of the impacts of human-caused climate change. Sea levels are rising globally, but Oregon's coast is rising because of tectonics. So we're not going to see a sea level rise signature. California is burning like mad. We're beginning to burn, but not like California, but we are seeing our glaciers retreating. We've lost more than half of them. So there's a good signature of that. Into the future here, there's this graph here I'm showing you from 1950 up to 2100. The blue line is showing you the summer temperatures for the Cascades following what's called a representative carbon pathway. So this one is about, would result in 2 degrees C of global warming. And this is, we want to shoot for 1.5, but as of right now, we're still on this red pathway. But if we do this, moderate our carbon usage in the the next couple decades, we're still looking at 4 degrees Fahrenheit of warming by 2050 and 6 degrees Fahrenheit by 2100. That's a lot more. I mean, we just had 3 degrees kill off half the glaciers in Oregon. Now, if we don't do anything about carbon and kind of go on this business as usual scenario, which is called representative carbon pathway 8.5, and has 4 degrees C of global warming, 8 degrees Fahrenheit global warming, that's going to warm the Cascades by more than 5 degrees Fahrenheit by 2050 and 11 degrees Fahrenheit by 2100. That's an insane amount of warming that will fundamentally change our high alpine zone. So if this is what we're looking at for the future if we don't change our carbon usages. So what we are doing as the Oregon Glaciers Institute is trying to at least monitor the changes in these glaciers and see how they are responding to what globally humans do with carbon. And for this coming summer, we want to determine the area of ice remaining in Oregon. So really get a firm number on how much ice remains. And from that, build a monitoring network. But before we even build a monitoring network, we really want to understand how these glaciers have changed since the Little Ice Age up to present to develop a relationship between temperature change and glacier response that can allow you then to take those temperature records for the future and project how these glaciers will respond. And to even do that better, we want to start monitoring the glaciers and observing their ins and outs, which is called a surface mass balance program. So going out on, say, we've chosen Crook Glacier and Hayden Glacier in the Three Sisters in Broken Top region, where these these blue dots would be areas where we measure the amount of melt that occurs on the ice. And then the red square diamond, the red hexagons are where you'd measure the incoming snow. And this is called a benchmark glacier program that has been developed by the U.S. Geological Survey, but early only implemented in the North Cascades and in Glacier National Park, leaving the rest of the lower 48 to fend for themselves. And so this is our plan for the near future here, to really monitor the changes in glaciers, as well as looking at hazard development and how they're responding to this climate change. So what you can do here for helping us out is just find a little pitch here. We are a 501c3, and so we are able to do this work thanks to financial contributions from concerned citizens like yourself. So please, if you feel inspired, donate to us. And then on top of that, we really can use photographs of glaciers. And a photo is really worth thousands of person hours going into the field, because everybody's going around with a cell phone nowadays. We'd really appreciate any photos you have of the glacier terminuses so we can see how they've changed. And in particular, it would be great if you have photos from before 2010, before everybody had a cell phone in their pocket that took great photos. Those are priceless images, because we don't really know much about how the glaciers changed in the 50s, 60s, 70s, 80s, and 90s. And after 2010, there's boatloads of photos on the web that you can look at. Just open up Google Maps and there's photos everywhere. But prior to 2010, not a lot's known. So we have a way that you can submit your photos on our website. And lastly, if you're interested ever, we're looking for people to join us in the field too, to help us out with field work. So thank you for your time, and take any questions. And yeah, here's my kiddos learning how to self-arrest with my co-founder, Aaron Hartz here, who also runs the Central Oregon Avalanche Center. So if you're ever out in the backcountry and reading the avalanche reports, odds are he probably wrote them. So thank you.
Thank you, Anders. Yeah, folks, if you could start to enter your questions in the chat, I can go ahead and read those off. I'll just tell you some of the information that's so crucial here and absolutely requires action. Glaciers are climate recorders. That's going to stick with me for the rest of my life. I think that that's such an important statement. That glaciers are a natural reservoir. Another really important statement and information to understand and knowing where your water really comes from. That Crook Glacier feeds the city of Bend drinking water. Another thing that I really needed to know. So great, crucial information that requires changes and just important messages. So we have a few questions coming in, Anders.
Mm-hmm.
A question here from Jim. How long ago were the moraines on No Name Lake formed?
Well, those are from the Little Ice Age. And so ice was probably filling that basin at least up until 1850. When the Little Ice Age ended in Oregon is not well documented. By the photos you start having, the earliest photos are from the 1880s. And you see ice at those moraines, but they've usually thinned below the top of it. So it's already beginning to retreat from the moraine. Jim O'Connor, who made the USGS study I mentioned at the beginning of the talk, he has cored a couple of trees on those moraines, and they date to 1850. So the maximum of those moraines being deposited was 1850. Those tree records, one is from Jack Lake, or from Jack Glacier on Three Fingered Jack, and the other one is on the South Sister. So for No Name Lake, I guess you'd say it's not directly known. It's assumed that all the glaciers in Oregon behave the same as these two places they actually have measurements, but precisely you can't say. But probably 1850s.
Kevin is asking, when did Palmer Glacier die on Hood?
Good question. And I think it really was a glacier. Some people say it wasn't, but there's evidence of the U.S. Geological Survey measured the thickness of the ice in 1981. It was 150 feet thick at its maximum. So it was an active glacier. It was thick enough to be an active glacier in 1981. Looking at photos you can find on the web, you can still see ice there in the mid 80s. And I think by 1990 or so, it probably was no longer an active glacier. And it's definitely not there now. My son and I were up on my birthday on October 7th up there, and there's just a little bit of snow left. Timberline Lodge doesn't show you the photos of what it looks like at the end of October. It's not,
Right.
it's bare bedrock. It's not the snowfields we like to think it is.
Right. Sid's asking, if warming is arrested, can dead glaciers come back to life?
Yes, they can. I mean, we snow like mad here. And if we make the summers cooler and make the winters cooler so we get more snow and less rain, there's not, it easily can come back. Yeah. It's, it's not, it's, the glaciers are small enough that it's not this kind of threshold thing you hear about with uh, ice sheets disappearing and then you no longer have this cold reflective snow and then now you have bare warm bedrock. These things are pretty small. They're more responding to the actual temperature and also the precipitation than being a self-sustaining ice mass like an ice sheet would be. Southern Greenland ice sheet extends down to 60 degrees north and you go over to Scandinavia, it's warm and sunny, and so there's ice exists in southern Greenland because ice exists in southern Greenland.
Okay. Mark would like to know, isn't the groundwater that we use for Bend drinking water also indirectly fed by the glaciers? So loss of glaciers is even worse.
Yep, exactly. So yeah, the other water source is the Bend is the groundwater, and that is also being fed by the glaciers. Now that leads towards a lagged response time, and so you're basically taking your water and slowly moving it through a subterranean network of volcanic tunnels and volcanic debris. But yeah, over decades that will become depleted as well from no longer being recharged and just being sucked out, which is one way to think of Bend is it's Bend, Tucson, and Reno are desert communities that live next to high mountains that have a lot of snow. And in the case of Bend, also glaciers. And those things exist as sustainable areas because they have this alpine environment nearby. And Phoenix and Nevada do not. And Phoenix and Las Vegas do not. And so losing the glaciers and the snow will transitioning Bend from being a sustainable, water sustainable community towards a water unsustainable community. It's not good.
Yeah. Kevin, glaciers collapsed maybe twice on Hood in the 90s. Yes. Do you know which ones?
Yeah. The one that's flooded a lot is White River Glacier coming down. It takes out Highway 35. And that's happened 20 times at least since 1907 when the highway was first constructed. And that's the kind of thing that can start happening more and more because you have this ice body up there and you're getting, the warmer the winters get, the more rain on snow events, the more rain on glacier events we have. The glaciers retreating, producing more and more meltwater in the summers than it normally would because the summers are hotter. And then it's all being held back behind these poorly consolidated natural dams of moraines that can break apart themselves. And so it's going from a stable situation to an unstable situation. And during that period, the next stable place is ice-free conditions. And so that transition period where the ice is disappearing is really dangerous. And on top of these glacial lakes forming behind moraines, you can also have subglacial lakes form, which are hard to detect unless you have GPS monitoring devices stations on the glacier itself, and those can form and catastrophically drain. And the one that happened in 1999 or 2000 on Mount Hood, White River, that was a subglacial flood. So nobody could see that water body filling up under the ice, and then it broke through and took out the highway again numerous times. Yeah.
James is asking, is the annual temperature change on Three Sisters greater than the annual temperature change on Earth?
Yes. That it's warming, basically the high alpine zone. It's debated whether or not this is a real feature, but if you look at the direct measurements, it is warming up there faster than the lower elevations are. And the regions, the higher you go in latitude, the warmer the rate of warming is faster because we have feedbacks where instead of having snow on the ground, we have bare ground in the winters. And so there's that the bare ground absorbs more of the sun's energy and warms up the air there locally. And so we are in a zone where by transitioning from snow or ice to bare rock in the winters and going into the summers, you can then make more warming occur because we just are absorbing more of the sun's energy than we used to and keeping it down here rather than reflecting it back into outer space, which occurs with bright surfaces like snow and ice. Yeah.
Okay. Andrea is asking, other than reducing our carbon footprint, what can we do?
Good question. And this is where we get to the double-edged sword of our glaciers being in wilderness areas. In the Alps and in Norway, places that definitely use glaciers, and they see them as a water resource in addition to just being this beautiful alpine environment. There, they can put blankets on the glaciers. Timberline Lodge, by building that, putting up Palmer Lift and skiing on Palmer, has helped preserve that glacier longer than it actually would have existed to the late 80s. And at Snowfield there, they are keeping snow there throughout the summer that would otherwise disappear. So that's actually helping sustain the streams, despite people being, sometimes being upset about there being here's a ski lift on the mountain and it's screwing up the environmental, this beautiful alpine environment. By grooming the snow there, they are actually making it brighter and slowing the melt that would otherwise occur. So by putting ski areas and grooming it and putting blankets on a glacier like they do for Rona Glacier, we can't do that in our area because they're all within this wilderness zone where we can't even take a chainsaw on to clear the trails. You use a handsaw. So nothing, that's the reality of our laws, how they're set up. In a way, it's like Star Trek. Almost every episode of Star Trek was they come across a planet that's having a major catastrophe, and they have the prime directive saying you can't interfere with the planet. So what do? So we were externally forcing these glaciers to respond to this carbon in the atmosphere. They're putting more and more in, but we can't go in and do the manual things that would help preserve this water resource. And so it's this conflict between preserving the natural environment, but globally we're hurting the natural environment. So it's difficult. Yeah, it's a Star Trek episode.
Kevin's asking, have we had any other glaciers catastrophically collapse? Any local here, Deschutes, and potential ones here? And then he has a follow-up question, but I'll go ahead and let you answer that.
Catastrophic collapse, not that I know of. I guess the term collapse, collapsing usually is inferring some kind of dynamic instability that you'd hear about, like West Antarctica collapsing, which still is a century timescale thing, but that's, this continent collapsing into the ocean there. They can melt rapidly. We don't really have the observations to say that. The good example I can think of is we had these spot observations. This guy, Steve Boyer, has a master's, he got a master's degree in the late 60s in glacial geology at University of Colorado, then went off and became a medical doctor. And he's kind of this major adventurer in the 70s and 80s and was well known in the Portland region as a great mountaineer. He went out in the early 2 decades ago, at the beginning of this millennium, and documented the extent of glaciers on Mount Hood, provided us those photos. And we've gone back at least to some of those sites and reconstructed them. And so Glisten Glacier on Mount Hood, 2003, when he took the photo of it, is a nice active glacier sitting there. And in 2020, it's gone. So in that sense, in 17 years, we can document a glacier disappearing. And that's really rapidly. But that's about as fine as we can get because we just haven't been observing these changes. So this is where submitting photos that I gave a talk, he saw it. Hey, I got all this records, and this summer I'd like to go out and revisit every spot he had, and let's look at what's happened in the first 2 decades of this century, this millennium, how much of glaciers are treated on Hood, because he did take nice, careful notes as a citizen scientist.
Yeah. Kevin said that you can still see the damage from the catastrophic implosion on Hood around Robin Hood area.
Yep. Mm-hmm. Yes, definitely.
Yeah. His follow-up question was, does the salt they add to Palmer hurt the glacier, help the glacier?
It helps the glacier by slowing melt. And I know it's controversial. It is controversial what that does to the fish downstream. When I've talked to the vice president of Timberline Lodge about this, and they're going to share their measurements they have and their weather station data to us. They've said their studies on the salt influencing the fish has been minimal, but I can't really comment on whether that does anything to the fish or not. But anything to slow the glacial melt helps the glacier, but it could hurt the fish. So you are adding salt to the environment that wouldn't otherwise be there.
Are there any other questions? It looks like that's close. We have them all. I am going to go ahead and put some contact information in the comments and chats, but again, I go back to the glaciers are climate recorders. That's, again, I'll continue to carry that message with me.
They are a climate station. We have weather stations that monitor the winds and what the temperature is today by the hour, by the second, by the minute. Glaciers tell you what the decade was like.
Yeah.
And if they're retreating, the decades are changing. That's the best way to put it.
Okay. Kevin asked, do you want pictures from only summer?
The summer is the best, but depending on when, we'll take anything. But ideally summer, because we really want to see the ice margin and where that is located, because that'll help us reconstruct the glacier change since the Little Ice Age. So we have like 1850, and then when they up through the late 1800s into the early 1900s, when they were going out, like the Mazamas were going out, they really took great photos, put a lot of care and effort into documenting everything they were doing. World War II hit, and we just it slipped by. And I saw initially a comment in there. One of the reasons I think why this has not been done is after World War II, when there was a lot of impetus to, a lot of money went into science and started the National Science Foundation and to the moon. It was a great time to be a scientist. At the same time, climate itself was conducive for glacier growth. Up through the end of the Little Ice Age, there were more El Niños, which in the Pacific Northwest mean warm, wet winters, which are bad for glaciers, and warmer summers, but it's mainly a wintertime signal. After World War II, we had more La Niñas. And in the 80s and in the early 90s, we started having more El Niños. And people might remember Chris Farley's skit in the early 90s about El Nino and the wrestler. The reason why he did that was scientists had just documented what an El Nino was. And so we didn't even know El Nino, La Nina existed until the early 90s. And so naturally, the state of the tropical Pacific was good for glacier growth. And then on top of that, people have sometimes made an issue out of this is why, we've had carbon dioxide in the atmosphere has been rising consistently since the beginning of the Industrial Revolution. So late 1700s, early 1800s, and it rose throughout the 1950s, 60s, and 70s. But glaciers stabilized, as that one graph I showed, and that was a global phenomenon. And they started to retreat again in the 80s and 90s. Why did that have that hiatus? And part of that was because of the El Nino, La Nina. But the other component was those emissions we were doing came along with particulates. So all the stuff that the Clean Air Act that Nixon signed in 1970 to clean up the atmosphere, those particulates were cooling the atmosphere. And you hear billionaires talking about, seeding clouds to try to make the earth dimmer to combat global warming. Well, we were doing that with our dirty tailpipes. And when we cleaned up our tailpipes so kids didn't have asthma in Los Angeles anymore, that allowed then carbon dioxide to start warming the climate. So it was, again, cleaning up our tailpipes so they didn't emit so many bad things for our lungs, just CO2 now and carbon monoxide, had also led towards a warming climate too, again. So there's both naturally and anthropogenic, but we had caused anthropogenic cooling from that. So one of the weird byproducts of cleaning up the atmosphere, or cleaning up our tailpipes, was we also warmed the atmosphere.
Great. Well, Anders, thank you so much. Of all the places around the world that you've been and studied glaciers, and you picked Oregon to make it your home and to be here for us at the Oregon Glacier Institute and to dedicate your life to helping us here. So thank you.
Thank you. This is great. And thanks so much for giving me this opportunity to reach out to people.
Yeah, we are, just to let everyone know, we are recording Anders' talk, and we'll share that link with everyone. We'll be able to provide all of those website information, coalitions information, and again, how you can help. So we're getting lots of thanks and great talk, Anders. So in our messages, I don't know if you can see those, but.
Okay. Thank you, everyone. Thank you so much.
Have a good night.
Everyone, bye-bye.
Thank you.